Okay, this is the first lesson in geometry, and our objective in this lesson is students will be, you're going to be able to describe what we call undefined terms, and then you'll be able to basically define some of the basic objects in geometry. So we start with our undefined terms. These are concepts that kind of form the foundations of geometry, but they don't have a definition really. They just kind of exist, and we just accept the fact that they exist. So the first basic undefined term is a point. I can describe it. It has no dimension, and it describes a location. So we denote a point usually with a dot and a capital letter. You've worked with points as coordinate points. We can put points on a graph, but again, it describes a location. The second building block of geometry is a line, and lines are infinite in length, so you cannot measure a line, and they are one-dimensional. They just have length. So if I were to draw a representation of a line, we have arrows on both ends. That's important. I can name the line with just like a lowercase cursive letter, and that would be called line L. We do that quite often, but we can also put points on the line, A and B, and label it using the points. To do that, you would just have the two capital letters with the symbol across the top. So it's important that there are arrows on the end of this symbol. That represents a line as opposed to a line segment, which is what we'll be talking about in just a minute. Our third undefined term is called a plane. So a plane is infinite in 2 dimensions, and it represents a flat surface that goes on forever. Okay. We won't be talking too much about planes right now, but we'll be talking about them later on in the year. So a plane can be represented by a parallelogram looking thing with usually a capital letter, and that's how we label it, and that's called plane P. Okay, the next are a bunch of definitions, because those are our 3 undefined terms, point, line, and plane. So now we're going to go through some basic definitions. Collinear points. Those are points that lie on the same line. So any 2 points define a line. So any 2 points in the world will always be collinear. But when you have more than 2, they might be collinear or they might not. If they don't line up, we call that non-collinear. Okay, so non-collinear points are not on the same line. So I'm going to illustrate both of these things. If I have points A and B, I can always draw a line between 2 points. But then if I have point C and all 3 of them line up, those 3 points are collinear. I can represent them in symbols if I write ABC with the line across the top. That tells me that even if I might be off a little bit in my drawing, by having this picture here or this symbol here, ABC, all lie on the same line. Now let's say we have point D out here. D does not line up with A, B, and C. So you can say A, B, C, and D are not collinear. They are non-collinear. Okay, line segments are next. So we're going to define a line segment. Okay, so this is kind of a lengthy description for something that's relatively simple. Line segments. Basically, a line segment consists of 2 endpoints and the set of collinear points between the 2 endpoints. So that's a very detailed description of what a line segment is. It consists of two endpoints. So here's endpoint A, here's endpoint B. The set of collinear points between the two endpoints. So that means collinear, all the points that line up between A and B. So that's the formal definition of a line segment. You can't just say it's a line with two endpoints because that doesn't make sense. You can't just say it's a part of a line because that's not specific enough. But that's the definition. Okay. Now in symbols, we can represent line segment AB with a line across the top and no arrows. So that represents the label of segment AB. So now we're going to talk about the word congruent, congruent segments. The word congruent, if two objects are congruent, that means they have the exact same size and shape. So congruent segments would have the same length. Okay, they share the same distance. So if I have a segment AB and I have another segment CD, and if you measured them, they were both the same length, even though my diagram might not look like that. You could say that you could write a statement, AB is congruent to CD. So congruence goes with the labels. I'm saying line segment AB is congruent to line segment CD. Oops. So if those two little hands you looked at, you saw that flash up. I was trying to move my screen up, but I'm in the wrong mode to do that. Okay, so anyway, number 8, we're going to compare that to equal segments. Okay. So equal segments have the same length. And what I'm trying to get at is that we use the equal sign when we're talking about measurement. We use the congruent sign when we are describing and using labels. So for the same two segments, I could say the distance, the length of AB is equal to the length of CD. So here is another thing that's new. If I want to represent the length of AB, I use the two letters together with nothing on the top. So that represents a distance, a measurable value. Okay? So as a description, segment AB is congruent to segment CD. As a measurement, I can say the length of AB is equal to the length of CD. It seems kind of picky, but these are the little things that we have to keep in mind when we are communicating in geometry. Okay, the next definition is array. Array has one endpoint and then the other end goes off to infinity. So if I'm going to draw array, I have a single endpoint and an arrow. So if I label this endpoint A and another point B, we have to be particular when we name this. We call that ray AB because you have to start with the endpoint. In symbols, it's AB with a single arrow on the top. But you have to remember wherever the endpoint is, that's where the non-arrow side goes. So AB, ray AB is not the same as ray BA here. You couldn't write it as, if I wrote this in that picture, that is not valid, okay? Because my endpoint has to be at A based on this picture right here. Okay, next we're going to define an angle. And an angle is defined as the union of two rays. So two rays that have a common endpoint. So that looks like this. If I draw an angle, here's your standard angle. We usually put arrows at the end. And I'm going to label this. I'm going to put A up here, B in the middle, and C on the right. The point in the middle, that's called the vertex. And we can label this angle several different ways. I can label it with 3 letters because I have 3 letters here. So I could label it angle ABC, or I could go in reverse, angle CBA. But you have to go in order, and the vertex letter has to be in the middle. Also, since this is the only angle that I see in the picture, I can also just call it angle B. And then sometimes we'll put a number in the middle, and we can call it angle 1. We do that a lot in our proofs when we start labeling angles because it's faster and more efficient than the 3 letters. So let me just show you if that's 3 letters and that's single angle B. If I have multiple angles at that vertex, so A, B, C, and now D, I can no longer call any angle here angle B because it's too vague. I don't know which angle you're talking about. So you have to use 3 letters when you have multiple angles from the same vertex. Okay, when we have opposite rays, so 2 rays that are connected that are pointing in opposite direction, that creates a line. So I can have a ray this way and a ray going the other way. We also call that a straight angle. And we know that angle measurement is going to be 180 degrees. Okay, there are 180 degrees in a line. So some other special names for angles. Complementary angles. Okay, complementary angles add to 90 degrees. All right, they don't have to be connected to each other. They're just 2 angles. When you add them up, they add to 90. And then we have supplementary angles. Supplementary angles add to 180. And again, they can be connected to each other, like this, or they can be separate and still supplementary. If they add to 180, they're still going to be supplementary. Okay, and then I want to talk about a linear pair because a lot of times kids struggle with what a linear pair is. Okay, a linear pair is 2 supplementary angles that share a side, so they are stuck together. And what they do is they form a line. But it's only 2 angles, so a linear pair would be something like this. If I label that angle 1 and angle 2, angle 1 and angle 2 form a linear pair. Okay, they have to be connected so they create a line. And the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. Angles on a line always add up to 180. So that's what a linear pair is. And sometimes you'll see the word adjacent. Let me see if I can spell it. Adjacent. Adjacent in this context, if 2 angles are adjacent, that means they share a side. So linear pairs are always adjacent. Okay, so previously I talked about a straight angle. We also have a right angle. And maybe this is number 15. Yeah, we'll do 15. A lot of definitions today. Sorry about that, but we got to get this out of the way. A right angle is 90 degrees. So, looks like that. To specify a right angle, I would put the little box in there. So the measure of angle A is 90 degrees. Okay? finally, we have vertical angles, and vertical angles are created when two lines intersect. And so yeah, it's the created when two lines intersect, and it's the angles opposite of each other. So if I number these angles here, for vertical angles, angle 1 and 3 are going to be equal to each other, and angle 2 and 4 are equal to each other. So vertical angles are equal. That means the measure of angle 1 is equal to the measure of angle 3. The measure of angle 2 is equal to the measure of angle 4. Another property of vertical angles is that there are 4 sets of linear pairs here. So adjacent angles are supplementary. They add to 180. So when you have these 4 angles in the when you have intersecting lines like this, the angles are either going to be equal to each other or they're going to add to 180. Those are the only 2 cases. And that's it for a rundown of the basic definitions of geometry.